Okay, so students, today we will be discussing erythropoiesis, regulation and niche. Okay, now erythropoiesis means the conversion of a stem cell into a working RBC. Okay, that is any stem cell, suppose any stem cell, when it is converted to a working RBC, okay, working or functional RBC, okay, functional RBC, this conversion process is called erythropoiesis. Okay, now if we want to learn actually what is erythropoiesis, you should first understand the site of erythropoiesis, that is where erythropoiesis actually takes place. You should at first know the site of erythropoiesis. Now listen, before you start bombarding me with your answers that it is bone marrow or something like that, let me give you one hint. Okay, that is the site of erythropoiesis actually depends on what? Age of the person. That means this is the most important thing you need to understand. That is, the site of erythropoiesis actually is not a single site, but it has multiple sites depending on the age of the person. Okay, now listen with all your attention possible. The erythropoiesis, actually the process of erythropoiesis occurs throughout our life. The process of erythropoiesis occurs throughout our life. Now important point you need to understand is the process of erythropoiesis actually has two stages, that is stage 1 and stage 2. Okay, there are two stages of this process. Okay, erythropoiesis. Okay, now first things first, that is what is the stage 1? What is the stage 1? Okay, now the stage 1 is also known as the fetal stage. Okay, the fetal stage of RBC production. The fetal stage of RBC production. And the second stage, stage 2, is called the adult stage of RBC production. Okay, the adult stage of RBC production. Now you need to understand one thing, that we will at first discuss the fetal stage of RBC production, then we will talk about adult stage. Now listen with all your attention possible. That is, when we are talking about the fetal stage of RBC production, you should keep this in mind. That is, suppose a fetus is present in mother's womb for how many months? A fetus is actually present in mother's womb for a total of 9 months. Now this is the first month, second, third, fourth, fifth, sixth, seventh, 8th, this is 9th. Okay, so these are the 9 months. Okay, now In the fetal stage of RBC production, there are again divisions, okay, based on the month. That is, in the first month, suppose I am giving you an example. In the first month, suppose RBC is produced from site A in fetus, site A. Suppose in second month, RBC is produced from site B. That means you should always remember, in fetal stage itself, there are many stages which are involved, depending on the month of RBC production. Depending on the month, the fetus attains, and according to the month the fetus attains, the RBC production site also changes. Okay, now we should understand that basically, if we want to divide the months based on the sites of RBC production, there will be three divisions. There is first 2 months, that is here, then first 2 months, that is here, second from approximately 3 months, to this, okay, and then now you should understand that is there are three divisions. Okay, now in the first 2 months, RBCs are produced from, okay, RBCs are produced from, suppose this is month, and this is the production site of RBC. Production site of RBCs. Okay, now you should always understand that in the first month, RBCs are produced from mesodermal yolk sac. Okay, sorry, mesenchymal yolk sac. Okay, and now listen, in the first 2 months, the RBCs are produced from mesenchymal yolk sacs. Okay, now listen with all your attention. Suppose this is your ectoderm, and this is your endoderm, and in between this there is mesoderm, right? Now listen, from mesoderm arises, we'll have a detailed lecture on these things, that is embryology. Now listen, from endoderm, okay, yolk sac arises, okay, and there is yolk. Now listen, here in these areas RBC production starts. Okay, now the RBC production starts in the first month in the yolk sac area, but mesenchymal yolk sac, but it lasts only for 2 months, that is first and second month. Okay, now listen, for this phase, okay, for this now, oh, I have forgotten one very basic thing. When RBCs are produced from mesenchymal yolk sac, then it is called, please switch off your mobile, please switch off your mobile. Now when RBCs are produced from mesenchymal yolk sac, Okay. Then this stage, these 2 months, this stage is called mesoblastic stage. Am I writing it? Yes, it is called mesoblastic stage. Okay, this is called mesoblastic stage. Now, in these stages, that is in these months, okay, the production of RBC, the site of production of RBCs shifts from mesenchymal yolk sac to liver. Okay, now listen, the main site of RBC production during these months 3, 4, 5 and 6 is liver, fetal liver. Okay, now this is the primary RBC production site. Okay, but when we are talking about this stage, this is called actually hepatic stage. Okay, this is hepatic stage of RBC production in fetal life. Now, when we are talking about hepatic stage, you should understand, okay, that is liver is the primary RBC production site. It is the primary, right? It is the primary RBC production site. But you should always understand that there is also a secondary RBC production site, which is spleen, and other lymphoid organs like lymph glands. Important point to understand. Okay, so spleen and lymphoid organs, these are secondary RBC production site. This is secondary RBC production site. Okay, now this stage is called hepatic stage. Okay, now I have written here, so I shall write it here. That is this stage, these 2 stages, these 2 months actually is a part of mesoblastic stage. Okay, now I shall clear these things. Now listen. This stage falls under the hepatic stage. Okay, now in mesoblastic stage, mesenchymal yolk sac takes up the responsibility of producing RBCs. Okay, now in mesoblastic stage there is no primary or secondary RBC production site, but in hepatic stage the primary RBC production site is liver. That's why it is called hepatic stage. That is, you should always understand the fetal RBC production stages are named according to the primary RBC production site. Okay, and the secondary RBC production site during hepatic stage is spleen and other lymphoid organs. Clear? Okay, so right now we are dealing with the hepatic stage. Now we will start this last phase of RBC production in fetal life, that is called myeloid stage. This is called myeloid stage. Okay, now listen with all your attention possible on this earth. Myeloid stage. Listen, whenever I am talking about this single term myeloid, that means I am talking about bone marrow. Myeloid actually means bone marrow. That means myeloma means bone marrow cancer. Okay, we have discussed in monoclonal antibody class, right? Now listen. So myeloid stage occurs for 7 to 9 months, that is last 3 months. Now you should always understand, during the myeloid stage okay, the primary RBC production site is in myeloid stage. The primary RBC production site should be what? Bone marrow, right? And the funny part which you need to understand is the secondary RBC production site is liver. That is, the primary RBC production site during hepatic stage was liver, but in myeloid stage, the primary RBC production site has been shifted from liver to bone marrow, but liver also produces some quantity of RBCs, okay. As it is producing a very much less insignificant amount of RBCs, that's why it is called secondary RBCs, okay. Okay, so now we will be discussing the erythropoiesis in newborn child and adult, okay. Okay, so now we will be discussing RBC production after birth, okay. Now you should understand that RBC production after birth has two phases, okay, has two phases. Okay, this is phase 1 and this is phase 2, okay. Now in phase 1 of RBC production, now this phase 1 actually starts from after the birth till 20 years, okay, and phase 2 starts from 20 years up to infinite, okay, up to infinite, okay. If infinite means what? Maybe 60, 70, till death, till life, okay. Now up to 1 to 20 years, this is phase 1, and in phase 1 bone marrow of long and flat bones participate in erythropoiesis, okay. Bone marrow of long and flat bones participate in RBC production, okay. In phase 2, what is the difference between phase 1 and phase 2 is this, that in phase 2 long bones like femur and to some extent flat bones and to some extent liver even can produce RBC. In phase 1 also liver also plays a very good role, okay. Now listen, but in phase 2 flat bones and to some extent liver becomes a secondary RBC production site, but the primary RBC production site is long bones. Now why this is happening? Because during this transition, long and flat, suppose this is a bone, okay. Now there is bone marrow. Now listen, when you are young, your bone marrow is equal to all the bone marrow in your body is equal to red bone marrow. That means when I am talking about bone marrow of a 20-year-old or an 18-year-old person, then I am talking about red bone marrow. But when I change this statement a bit, that is bone marrow of a 40-year-old, that means I am talking about both red bone marrow as well as yellow bone marrow. Now, how this transformation occurs from red bone marrow to yellow bone marrow, we will talk about that in details when we will talk about some basic of histology. But right now, when we are talking about erythropoiesis, we should understand that red bone marrow only produces RBC. Produces RBC, not yellow bone marrow. Now, why this yellow bone marrow is called like that? Because yellow bone marrows have fat deposition in them. Okay, shaft of bones which earlier had red bone marrow now have yellow bone marrow. Why? Due to this deposition of fat, and this deposition of fats lead to the conversion of red bone marrow to yellow bone marrow. Now, the remaining of the red bone marrows, okay, are actively producing RBCs. Okay, in fact, red bone red bone marrows not only produces RBC, they also produces WBC and other cells. Okay, hematopoietic cell. Okay, now suppose if I ask you one question, that is, suppose he is person A, and I have taken all his bone marrow, red bone marrow. Now listen with all your attention. Suppose he is person A, okay, and I have taken all his red bone marrow here. Suppose this is the whole of his red bone marrow. Okay, this is the whole of his red bone marrow. Now you should understand one thing, that is, if I ask you people, that is, what is the percentage of this whole bone marrow from this person which is producing RBC? You understood my point? Wait, I am repeating the question, listen with all your attention. If I tell you that suppose this is 100% of this person A's red bone marrow, now you tell me what is the percentage of this bone marrow which is producing RBC? Now this is a very tricky question, and you should understand one thing, that is 75% of red bone marrow produces cells other than RBC. Okay, now you should remember all these things. 75% of red bone marrow produces cells other than RBC, but 25% always produces RBCs from red bone marrow. Okay, that's a very basic thing you need to understand first. Okay, this is called this is not hematocrit. We'll talk about in details the concept of hematocrit value when we will talk about blood. Now listen, you should be confused now when I will be talking about blood, but when I am discussing RBCs, listen, blood is a tissue. RBC is one of the cell in that tissue. What is a tissue? Tissue means what? You can say tissue is collection of cells, and these are all the rubbish definitions. Now listen, what is a tissue? Tissue means there are two components in it. Number one, it has got cells. number one. Number two, it has got some material media, it has got some what wait, listen, it's a very much bad situation here. Now listen, tissue is made up of what? Tissue is made up of two things, that is cells, and tissue is made up of tissue is made up of cells, and to support these cells we have oh my god, one of the person is telling membrane and I am writing it, oh my god. Matrix supports these cells by providing some very basic things known by the name of trephons. Mostly trephons are used by WBCs, but still, okay, that means matrix is actually the non-living portion of a tissue which actually supports the living portion, cells. You should understand this first. Now listen, in blood there also are two things, that is cells, and these cells we divide into three categories: RBC, WBC and megakaryocyte, from which we get platelets. And the matrix is absolutely correct, it is plasma. Clear? Now to differentiate, suppose if I take blood here, suppose in this test tube I take blood here. Now listen, suppose in this test tube I take blood, and I just simply, I am not disturbing this blood, and I have kept it overnight, suppose, okay, not overnight, for some times. What will happen is I will be getting a clear distinction between this layer and this layer, that is, this is the cell coagulates, and this is the clear plasma. So this is the plasma and this is cells of bloods. Now listen with all your attention. You should always understand, suppose this is 100%, okay, now 55% of this whole blood is equivalent to plasma and 45% is equivalent to cells, okay. Now what is hematocrit? You know what is hematocrit? You have got hematocrit tubes and all the things, you don't know what is hematocrit, oh my god. Listen, if you take hematocrit tubes like this and there are some markings, 1, 2, 3 or something like that. Now listen, suppose this is X, this is Y, this is Z, this is A, B, C, D. Now listen with all your attention. Okay. Wait. Suppose this is 1, 2, 3, 4, 5, 6, 7. Okay. Now listen. If I put blood here, and I keep it for sometimes undisturbed, then suppose this is my cell clumpings and this is my plasma. Now listen, how to find out hematocrit, right? How to find out hematocrit? Hematocrit is equals to 5, that is the in hematocrit tube, the reading which touches the first layer of blood is 5 and last layer is 7, that is 7 minus 5, that is 2, divided by what is the total length of this tube? 7, 2 by 7. This is your hematocrit value. This is how you calculate hematocrit values. It is there in your book by the name of boron and ball pip. It is there in your book. You have not read it. Oh my god. You should read that book very well. Okay? Clear? So now we will be discussing that how stem cells play a role in RBC production, and we should also concentrate on various cytokine factors which help in the production of RBC from a committed stem cell. Okay, and we will also be discussing what is a committed stem cell, what is uncommitted stem cell, what is pluripotent stem cell, what is totipotent stem cell. There are more things to learn. Okay, okay, hold your breath, stay with me, and we will now start with stem cell biology of RBC production. Okay, clear.